Hello, my friends. We're going to go over the quiz first, and then we're going to hit some notes after. So let's go through and see if you did it correctly. So the graph of y equals f of x is horizontally stretched by a factor of 1/4 about the y-axis. Now, if we go from words to mapping, that number stays the same. But if we go from words to equation, it always flips. So we're going from words to equation. So that number, instead of it being 1/4, is going to flip. It's going to be reciprocal, and it's going to be 4. So A and B are both out. And it's horizontal, so it's going to be with the x. And then it's translated 5 units to the left and 3 units up. So both of these are plus 3 at the back, so that didn't narrow it down. Now remember, when I told you, if you're moving to the right or the left, you have to make sure that you have what in front of your x? You need to have a positive 1. If not, you have to take a GCF out. So for this example, which I hope you didn't pick, it's going to have an f. I have to remember to take that 4 out because I need to have a 1 in front of my x, or else if I don't have a 1 in front of my x, my horizontal translation is wrong. So I take the 4 out, I get 4x divided by 4, which is 1x, yay, and then 5 divided by 4 is just 5/4. So C is actually, I don't know why I said that way, actually 5/4 to the left, not 5 to the left. And we need 5 to the left, so it's going to be D. Number 2, the graph of y equals 1 over x, so that's a parent function. It's one that hasn't been transformed. Remember, life is so much better when it's one that hasn't been transformed. So we have y equals 1x is transformed to the graph of y equals 1 over 5 bracket x minus 3. So that's all affecting my x, so that's all going to be horizontal. And then plus 4 at the back is my vertical. So by a series of transformations, one of these transformations is a vertical stretch about the x-axis. Now you're like, what the heck? There's a 5 in the denominator. But remember this? When we did this before, so say we had 2y equals fx plus 3. Remember when we had that? We could divide by 2. And instead of leaving a division of 2, what did I tell you you could do? I told you you could bring the half to the front. Instead of division by 2, it's a multiplication of a half. And so we actually have a vertical stretch by a factor of a half, right? So let's think about it this way now with this one. So if I have that division of 5, what could I have actually done? Yes, I could say that's a horizontal stretch by a fifth, and I'd be completely correct. Problem is, they didn't give me that as an option. So I have to change my equation. It's going to be y equals, and then I can bring 1/5 to the front, bracket 1 over x minus 3, plus 4 to the back. So this is actually a vertical stretch about the x-axis by a factor of 1/5. Except it says to the nearest tenth. So we go to our calculator, and we go, put down marker, so I go 1 divided by 5. Boom, 0.2. That's my answer. It's to the nearest tenth. 10 has how many zeros? 1. So the tenth has 1 decimal place. So it was 0.2. You always fill in left to right. And keep in mind that the numeric response boxes only have decimals in this box, the second one. Oh my goodness, I can't talk today. And the third one, or where the decimals are. So if I have just like decimal 2, I have to go 0.2 because I don't have a decimal bubble in the first box. Okay? Now let's look here. The points 2, 4, and 4, 2 are on the graph of y equals f of x. So they're on the original. If the function f is transformed to the function g, where g of x equals 2, f 2x minus 1, then the points p and q are transformed to r and s respectively. Respectively means in that order. So p is going to become r, and q is going to become s. Now the key thing we have to remember here is if we're moving coordinates, we must use mapping. Yes, mapping is what we're going to use. So words and mapping are the same. So I'm going to do the x stuff first. So I'm going to get x, y becomes. Now this is the only thing affecting my x, and it's a horizontal stretch by a factor of 1/2. That's what I say. So my mapping is going to have the same number. Remember, what I say, I do in mapping. So if I say it's a horizontal stretch by a half, I'm going to have a half in mapping. That's it. That's all affects my x because it's the only thing in that bracket. Now I have a vertical stretch by a factor of 2. So I said 2, I'm going to write 2 for my mapping. And when I stretch and reflect, I multiply. When I horizontally, vertically translate, I add or subtract. So I'm going to multiply it by 2, and then I move 1 down, so I have to subtract 1. And then I just apply it. So the hardest part is really the mapping. Once you have that, if you have it correct, now you're just plugging in stuff. So we're going to go 2, 4. So this is P. I don't know why I made that comma so high. Looks like 14. 2, 4 becomes 1/2 times 2, comma 2 times 4 minus 1. So I'm going to get 1/2 of 2 is 1. 2 times 4 is 8, minus 1 is 7. So I get 1, 7, so respectively in that order, 1, 7. Then I have to do Q. Q is 4, 2. And it's going to be put in for 1/2 times 4, comma 2 times 2 minus 1. So I'm going to get 2, comma 3. Because half of 4 is 2, and then 2 times 2 is 4, minus 1 is 3. So 2, 3. So 1, 7, 2, 3 will be the answers to the quiz. And you're going to have the notes handed out now for polynomials, the first lesson. So we're looking at remainder theorem, section 3.2 in your textbook. So we could use long division. You can use long division to divide a polynomial by a binomial, so something with more than 2 terms, or could have 2 terms, by a binomial, something with 2 terms. You can use long division, and you get the polynomial divided by the binomial equals the quotient, the answer, plus the remainder divided by the binomial. The components of long division are the dividend, so the polynomial, p of x, which is the polynomial that is being divided, the divisor, x minus a, which is the binomial that the polynomial is divided by, the quotient is q of x, which is the expression that results from the division, or the answer, the remainder, r, which is the value or the expression that is left over after dividing. To check division of a polynomial, you can verify the statement that the polynomial should equal the binomial times the quotient plus the remainder. So you should be able to get your polynomial back. That's long division. We have a faster method, which is called synthetic division, and it's a short form of the division that uses only the coefficients of the terms. It involves fewer calculations, and it makes people much happier. Okay? We're doing neither of those today. We're literally just looking at the remainder theorem today. So this is going to sound like gibberish at first, but it's going to make sense, and we'll come back and reiterate it at the end. So when a polynomial, p of x, is divided by a binomial, x minus a, the remainder is p of a. So that means if I take this factor, x minus a, I set it equal to 0, I'll get x equals a. If I take that value and I plug it into the polynomial, this is like f of x, I take whatever the heck is in for x, plug in the polynomial. P of a, I take whatever the heck a is and plug it in for all the x's in the polynomial, and I'll get the remainder. Okay, which we'll go over in a second. If the remainder is 0, so if when I plug in for that value, using the remainder theorem, I get an answer of 0, which would be the remainder, then the binomial x minus a is a factor of p of x, so that's important. If the remainder is 0, then the binomial x minus a is a factor of p of x. A factor, because sometimes it will just say x minus 3 is a factor. Well, when they say is a factor, and you see is a factor in this unit, I'm going to write it in large print, is a factor, that's a fancy way for them to indirectly tell you, so when I see that, they're indirectly telling me that the remainder is 0. Very important. So if they ever say x minus 2 is a factor, then they're telling me that x minus 2, when I plug that in, I'm going to get a remainder of 0, which is super important. So we're not going to do long division or synthetic today because I'm doing this through a podcast. We're going to do just the remainder theorem to determine the remainder. Okay? Now, what we will be doing is, in the polynomial unit, we are going to be factoring things that we can't just factor by product sum or decomposition or difference of squares. So until now, in grade 10 and 11, we only factored quadratics. So the largest thing we factored was an x squared. Well, that's over. In grade 12, we're going to factor degree 3 or x cubed functions. We're going to factor degree 4, which is x4 functions, or degree 5. And that's what we're going to max out at is x5. Anything larger than that is outside of our curriculum, so we literally stop there. Okay? So they want us to determine the remainder. Well, let's go back to my definition up here, this little spot. It says when a polynomial p of x is divided by a binomial x minus a, the remainder is just plugging in that root, that a. So let's try that. Okay, that's what we're going to do. So we're not going to do long division or synthetic. We're going to just fill it in here. We're going to do remainder theorem. Remainder theorem is all we're going to do today, okay? I don't care if you fill it into the long division spot or the remainder theorem spot. I would fill it into the remainder theorem. I just don't have a lot of room to see it, so I'll write it down there, but I'm going to do some work up here first. So I told you that we can't just directly fill in the factor. We have to fill in when we solve for the factor. So I'm going to go over here, I'm going to go x plus a, in this case it can be x plus 1 equals 0. And then I need to solve for x. So I'm going to subtract 1, x equals negative 1. So to find the remainder using remainder theorem, I'm literally going to find p of negative 1. So down here I'm going to write my polynomial out, so I have it. So p of x equals x cubed plus 4x squared plus x minus 6. And then I have x equals negative 1. Now we're looking for the remainder. Remember back into the younger years when you did long division, this may bring back great memories or make you want to crawl under your desk. Either way, you did do long division. So if we did 78 divided by 3, let's say, okay? So what did I do? I went, how many times does 3 go into 7? Fully. 2, so I put a 2 up here. And then I go 3 times 2 is 6. Great thing is we're not testing your grade 6 division skills, so I'm just reminding you. So we subtract it, and we get a 1. Then I go and drop down to 18. And now I go 3 times 1 is 18. It's 6. 3 times 6 is 18. Subtract and I get a 0. So I would have a remainder of 0. If I had 10 or 3, well, 10 would be stupid. If I had 2 or 1 left over, it has to be less than the divisor, then that would be my remainder. So all we're doing now is we're finding the remainder into an advanced polynomial. Okay? Not just a simple double-digit number or triple-digit number. We're looking into an actual polynomial that has variables. So, going back, how do I find the remainder? Well, I solve for my x. I'm going to write that down. How do I find the remainder? How do I do remainder theorem? Step 1, solve for x. And I'm going to put x in quotes because the variable doesn't have to be x. They could have an a or a p. They could use whatever variable they want. Most often it's x, but they can use whatever they want. So how did I solve for x? Well, up here. This was my step 1. I set my factor equal to 0, and I solve for x. There, up there, step 1. So I'm going to label it step 1. So step 1 is solve for x. Step 2, step 2 is substitute. Substitute x equals whatever you solved for into the polynomial. So this is where we do function notation. So in this case, we're going to go do it in a different way. P of -1. What does that mean? Whenever I get this function notation, whatever's in this bracket goes in for the x's in the polynomial. So I'm going to get -1 cubed plus 4 -1 squared plus I flopped the numbers. Oh my gosh, I was using colors and then so then I go 4 -1 squared plus -1 minus 6. So you see I just put -1 in for these x's. And when I substitute, I always put the thing in brackets. Okay? Now this stays the same, P of -1. We can just keep rewriting that. P of -1 equals -1 cubed. If you put it into your calculator, either way you're going to get -1. But -1 squared is actually +1. Remember I showed you this? If you go -1 squared without brackets, it's going to tell you it's -1. And we know that a negative raised to any even exponent is positive. What your calculator needs to see is that you want to square -1. Here we just had a negative sign and we were squaring 1 above, up here. We were squaring the 1 first and then just dropping a negative sign, and that's why we got -1. -1 squared is actually +1, and we should know that whenever we square any negative, or to the 4th, or to the 6th, or to the 8th exponent, it will always be positive. So we're going to get plus 4 times +1 minus 1, because plus and minus 6. Do I have to show every little step in between here? No. Am I showing it to you? Yes. -1 plus 4 minus 1 minus 6 equals -1. -1 is -2. Minus 6 is -8. Plus 4 is -4. So our actual answer looks like this. P of 1 equals -4. What does that mean? That means the remainder is -4. So when I do long division on this, I would get a nice little remainder of -4. So the other thing we can say, this one just asked us for determine the remainder, which is good. We're done. But I want to go one step further. The remainder is -4. So does that mean that, and it's P of -1, sorry. Does that mean that x plus 1 is a factor? Remember back here we had x plus 1? They didn't ask us this, we're just stretching this. So is x plus 1 a factor? Nope. Look right here. It only is a factor if the remainder is 0. So I can say x plus 1 is not a factor. I know it didn't ask that, but we're sending that little thing home. So every single time we find a remainder, we're going to check and decide if it's a factor or not. Next page. So you are going to try this one. So step 1, solve for x. So we're going to get x minus 1 equals 0. So we add 1 to both sides, and we're going to get x equals 1. Now we're going to find P of 1. We're going to do function notation, which means we're going to plug it in for all of our x's. So we're going to get 1 cubed plus 1 squared minus 1 plus 3. Because we're going to divide x cubed plus x squared minus x plus 3. We're going to divide that polynomial by x minus 1. And we want to know what is the remainder. So whenever they ask for just the remainder, we can use remainder theorem, which is this. So we're going to get 1 cubed, which is 1, plus 1 squared, which is 1, minus 1 plus 3 equals 4. So the remainder is 4. Now you know what I'm going to ask you next. Is x minus 1 a factor of that polynomial? No, because the remainder is 4, not 0. So this is just a little side note. I know it didn't ask us for this, but we're going to do it as a side note. X minus 1 is not a factor. Now you're going to try 3. Find the remainder when 2x cubed minus 4x squared plus 3x minus 6 is divided by x plus 2. Try number 3. So, first thing we're going to do is solve for x. So we're going to go x plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. Then we're going to find the function notation of that. So p of negative 2. So we're going to get 2 times negative 2 cubed, because we're going to sub negative 2 in for every x in the polynomial, minus 4 times negative 2 squared plus 3 times negative 2 minus 6. To reiterate, we're plugging it in for the x's. We're substituting in for the x's. So those x's will all be replaced with negative 2. So it's going to equal 2 times negative 8 minus 4 times 4 minus 6 minus 6, which is negative 16 minus 16 minus 6 minus 6. Negative 16 minus 16 minus 6 minus 6 equals negative 44. So we can technically write p of negative 2 equals negative 44. So we can say the remainder is negative 44. And our little side thing that I told you we're going to do for each one, even though it doesn't ask us for it. All right, here's our x plus 2. That's our factor. X plus 2 is not a factor because the remainder is not 0. So those are all ones where they literally just ask you for the remainder, which is setting you up to be able to do number 4. Remember, we're only doing remainder theorem again. So we're going to do method 2. So we're going to write down here. So it says when x cubed plus 5x squared plus kx minus 8, this is different, we have an extra variable, is divided by x minus 3, the remainder is 1. This is different, they gave me the remainder. Note, this could be given as p of 3 equals 1. How is that? Find k. Let's go back here. I wrote the answer up here as p of negative 2 equals negative 44. So let's break this down. This is the x equals number. This is the remainder. We agree? So whenever we are missing a variable, so in this case when we're missing a k, so whenever, I'm going to move this up a bit, whenever we are missing a variable, not the x's, like the second variable. So this time, they're making us find a k or determine a k. We must do p of x equals remainder. Okay? So in this case, we had x minus 3. So we're going to solve that. We're going to go x minus 3 equals 0, x equals 3. So great, we have p of 3. And then what does it do? P of x equals the remainder. And what did they tell me the remainder was? 1. So it's going to equal 1. So that's why we could write it in this form. Do you think on the test they're going to say, oh, and by the way, it can be written in that form? No. You're going to have to remember that when you're missing an extra variable, so in this case a k, we need to get it into this format. Why? Because now I can plug it in. Okay? So I'm just going to write it up here so I can plug it in going downwards. So p of 3 equals 1. What the heck does p of 3 mean? We've never taught this since grade 10. Grade 10 keeps coming back to us. Whatever's in that bracket needs to go into the polynomial for x. So we're going to fill it into the x cubed plus 5x squared plus kx minus 8 for the x. So the only variable that should be left is the k. So x cubed, so 3 cubed plus 5 times 3 squared plus k times 3 minus 8 equals 1. So we're going to get 27 plus 9 times 5 is 45 plus 3k minus 8 equals 1. 27 plus 45 minus 8 is 64 plus 3k equals 1. Subtract my 64. And I get 3k equals negative 63. Need to get k by itself. So I'm going to divide by 3. And k equals negative 21. Now, whenever we solve for these, we can check it. And I'm going to check it above. So I can check and see if I got the right k value, because I can plug it in for k. So I can get my polynomial. My polynomial, I'm going to not do synthetic division, so it doesn't matter. I'm going to use this space. X cubed plus 5x squared. K is minus negative 21. X minus 8. Now, how can I check this? Well, I can do P of 3, and hopefully I will get the remainder, which is 1. If I do, my k is right. If I don't, my k is wrong, or I happen to do my remainder theorem wrong. So I'm going to go 3 cubed plus 5 times 3 squared minus 21 times 3 minus 8. So I'm going to get 27 plus 45 minus 63 minus 8. So P of 3, so it equals 27 plus 45 is 72, minus 63 minus 8 is negative 71, 72 minus 71 is 1. So I got the right remainder, so I know my k is right. I can walk away on the test knowing I got this completely correct, and I'm happy. You're going to try number 5. Try it out. All right. So if we have P of 3 equals negative 12, what was our factor, just to check? So this would be x equals 3. So our factor would actually be x minus 3. Is x minus 3 a factor of this polynomial? Nope, because this is my remainder. Remember, it always equals my remainder, so x minus 3 is not a factor of this. And on the diploma, they can even not ask you to find k. They could ask you if x minus 3 is a factor, and then you'd have to be able to figure that out. Okay? So we need to know our rules. So they did not ask that. They asked us to find k. So we're going to do P of 3 equals 12. So we're going to go 3 cubed minus k times 3 squared plus 17 times 3 plus 6 equals 12. And we get 3 cubed, which is 27, minus 3 squared times k, which is 9k, plus 7 times 3, which is 51, I believe. Let's check that. You literally get to watch me do math, and I literally can figure this out. I'm sure it's 51, but I slightly don't remember. Trust my brain. Boom, I'm right. Yoo-hoo. Plus 6 equals 12. And then we do 27 plus 51 is 78 plus 6 is 84. Minus 9k plus 84 equals 12. And we subtract 84. And I'm going to get negative 9k, is canceled, equals negative 72. Divide by negative 9. K equals 8. And remember, we can check. We should be able to walk away knowing if we got this question right. We can check it. We could do P of 3 equals 12 with K equals 8. So we're going to go 3 cubed minus 8 times 3 squared, so filling that with K, plus 17 times 3 plus 6, and we're going to hope it equals 12. we're checking it. 27 minus 8 times 9 is 72, plus 51, plus 6 equals 12. And then we do 27 plus 51 plus 6 minus 72 is 12. So 12 equals 12, so I checked it. So I know I got the question right. Next question. So this is the last type of question we're really going to go through. We're going to do one big kahuna like this, number 6. But before we get to number 6, I'm going to do number 7. And I probably should have done it out of order in the notes. Every year I regret this, but I'm sure you can go to 7 and come back to 6 and be fine. So why would I do this one a little different? So this one is find the remainder when 2x cubed plus 3x squared minus 7x minus 3 is divided by 2x plus 5. The difference here is I don't have like x plus 3 or x minus 4 or x plus 5. I have 2x plus 5. So you still just solve for it. You're just going to get a fraction. So we're going to get 2x plus 5 equals 0. So we have to solve for x. Subtract 5 from both sides. 2x equals negative 5. Divide by 2. X equals negative 5 over 2. Now, that is 2.5, and you could use negative 2.5, but we're big kids, and we're in dash 1, so we're going to use the fraction. So I'm going to do p of negative 5 over 2. So I'm going to get 2 times negative 5 over 2 cubed plus 3 times negative 5 over 2 squared minus 7 times negative 5 over 2 minus 3. Now keep these in mind, they're over 1. So I'm going to show you the math. If you didn't do it this way, it's fine. 2 over 1, negative 5 cubed is negative 125, and 2 cubed is 8. You cube both numbers. Plus 3 over 1, negative 5 squared is 25, 2 squared is 4, minus 7 over 1, times negative 5 over 2, I'll just leave it like that, minus 3. So then we multiply top, top, bottom, bottom. Negative 250 over 8, plus 75 over 4, plus 35 over 2, minus 3 over 1. You technically would have to make common denominators, and half of you are like, I just plugged it in, Lepp, and I have the answer already. Why are you still going? Because I'm showing you actual math, so I need to make common denominators. So I do the bottom, I have to do the top. So I'm going to get negative 250 over 8, plus 150 over 8, plus 35 times 4 is 70 times 2, so 140 over 8, minus 24 over 8. So then I get negative 250, negative 274, plus 290. So then I'm going to get, I add up all the numerators, I'm going to get positive 16 over 8, which equals 2. And you're like, yeah, I plugged negative 2.5 into my calculator and I got 2. Great. It would still work. It would still be fine. But I love when we can go through and show the math that we've learned. Okay? Big kahuna question. Number 6. How is this different than what we did before? Instead of just missing a k, we now have to find 2 variables. We're going to really bring grade 10 back again. Okay? So this one says, when p of x equals 3x cubed plus mx squared plus nx minus 7, and it's divided by x minus 2, the remainder is negative 3. So this, if it's divided by x minus 2, the remainder is negative 3. I can write that as p of 2 equals negative 3, right? So if I solve this out, x minus 2 equals 0, x equals 2. I fill that in, equals the remainder. So I have 1. It is also known that p of negative 1 equals negative 18. Ruh-roh. I have 2 polynomials. What the heck? Yeah, you need 2. If you're missing 1 variable, you need 1 p of something equals remainder. If you're missing 2 variables, you need 2 of them. I know, life gets good. So the first step is to plug those in each separately. So we're going to get P of negative 1 equals negative 18. So we're going to do that first. So we're going to go 3 times negative 1 cubed plus m times negative 1 squared plus n times negative 1 minus 7 equals negative 18. So I just plugged it in. Now I'm going to solve. Well, solve is loosely, because I'm not actually going to find out what they equal right now. I'm going to do some math. So negative 1 cubed is negative 1 times 3 is negative 3, plus negative 1 squared is 1 times m is m. Negative 1 times n is negative n, minus 7 equals negative 18. Now I'm going to get everything together that's not the m and the n, because I'm going to collect like terms. Negative 3 minus 7 is negative 10, so I'm going to go m minus n minus 10 equals negative 18. And then I'm going to add 10. My goal is to get mn equals number. That might bring back some grade 10 in you. xy equals number. Maybe, possibly, maybe not. So that's my first step. Do the first one. Second step, do the second one. So I get p of 2 equals negative 3. There is nothing worse. This is reminding me of distance learning, where I did my podcast and I didn't talk to children. This is what I did not like about distance learning. So, yay, here I am talking to myself again. So we go 3 times 2 cubed plus m times 2 squared plus n times 2 minus 7 equals negative 3. My daughter, who's 6, decided to get a snotty nose, so I have to be home with her. That's why I'm not here. 2 cubed is 8. 8 times 3 is 24. 2 squared is 4 times m is 4m plus 2n minus 7 equals negative 3. Now 24 minus 7 is what? We're going to get 4m plus 2n. 24, take off the 4 is 20, and then take off 3 more is 17. And then I'm going to subtract 17 over. 4m plus 2n equals negative 20. Box it. Okay, you're probably freaking out. I had to stop for a sec because I knew something was wrong. Way back here, you see this negative 18 plus 10 in this general area here? You probably were freaking out a while ago. You're welcome, Mr. Banter. This is actually negative 8. Oops. Look at that. Negative 18 plus 10. That's negative 8. Okay, so you can see I can make a little oopsie in this very long math. But anyways, we're not done. So we get m minus n equals negative 8. 4m plus 2n equals negative 20. And here's where we go back to grade 10. Elimination. So we stack them on top of each other. M minus n equals negative 8. 4m plus 2n equals negative 20. Now I need to make the m's and n's match opposite signs so I can add the equations. So I'm going to multiply the top by negative 4. Both sides of the top. So that I have a negative 4m and a positive 4m. So I'm going to get negative 4m. Negative 4 times negative n is positive 4n equals 32. And then the bottom equation just stays the same because I didn't do anything to it. So you have to pick one of them to change. Sometimes you have to pick both. But in this case, I only did pick one because now my m's match. And now I can add them. And because I did opposite sides, I can add them. So 4m minus 4m cancels. 4n plus 2n is 6n. 32 minus 20 is 12. Divide by 6. And, n equals 2. So that's where I get my 1 variable. Then I have to plug it back into either this equation or this equation to get m. I'm going to plug it into the first one because it's more simple. So I'm going to go m minus n equals negative 8. These are my 4 steps. M minus n equals negative 8. And then I'm going to go m minus n is 2 equals negative 8. Add 2. M equals negative 6. Once again, I could plug these in for M and N, and I could check and see if when I plugged in P of 2 equals negative 3, I got left side equals right side. So my first step is plug in the polynomial, the 1, P of negative 1 equals negative 18, and get Mn equals number. The next one is plug in the other polynomial, P of 2 equals negative 3, and get Mn equals number. Third step, stack them. Then make either the m's or the n's the same. I made the n's the same but opposite signs so I could add them. If they're the same and the same sign, then you have to subtract them. And then it's like 1 minus minus 3. Oh, that's plus, which is more complicated. So I always make them opposite signs so I can add them. Solve for one variable. Fourth step, plug it back into one of the two box equations and get your n. Okay, that's it for today. Here are, oh my gosh, it's late at night tonight. I'm here on Sunday night. Here is your homework out of your textbook. I'll see you tomorrow because my husband is watching my daughter. Have a good day.